start. Good afternoon.
Good afternoon.
Okay. So children, in this period, we are going to do few questions from integration. Okay. Last class, we are discussing about integration of the form linear by quadratic, isn't it? Linear by quadratic and linear by root of quadratic. So this period, we are going to do few more questions in that form, linear by quadratic and linear by root of quadratic. One more. Okay. After that, one or two questions after doing in that form, we will start with integration by partial fractions. Write this one. See children, at that day itself I told linear into root of quadratic is deleted. Linear into root of quadratic is deleted. Okay, we have only the form linear by root of quadratic or linear by quadratic form is there. Okay, so write the question. Integral of evaluate integral of 2x plus 3 by 2x plus 3 by root of x square plus 4x plus 5. Check whether we did this question. Once again, please check it, children. We tried this one? No. Okay, no. Okay. Integral of 2x plus 3 by root of x square plus 4x plus 5. So this is of the form, which form? Linear by root of quadratic. If it is in this form, what is the method we learned? Numerator is equal to a into derivative of denominator plus b. Numerator is equal to a into derivative of denominator plus b. So now if, okay, so now equating coefficients of x. When you equate coefficient of x, what you will get? 2 is equal to 2a. Is or no? Acho, is it correct?
It not reach there now.
Huh?
I'm doing.
Ah, yes, you got the value of a.
No.
Ah, do it, do it. Achut, okay, for the exam also, don't write more elaborately. Keep it that one in your mind. Okay, you'll be taking more time for solving. That is the thing. For exam, that time is limited, and you are doing MCQ. That point. Okay, remember that one. Now, next step is you have to equate constant terms. Emmanuel, when you constant terms, what you will get? Equating the constant terms, what you will get?
B equal to -1.
B is -1. Very good. B is -1. Nandana, is it correct? B is -1.
Yes, ma'am.
Yes. Okay. So now look at this. When we substitute here, I will become integral of numerator. In the place of a, you can put 1. 1 into 2x plus 4 plus b is -1 by root of x square plus 4x plus 5 into dx. Root of x square plus 4x plus 5 into dx. So now we can split this into two integrals. 2x plus 4 by root of x square plus 4x plus 5 into dx minus integral of 1 by root of x square plus 4x plus 5 into dx. So this is of the form. Now look at here, whether the derivative of denominator is in numerator. So what is the integration of first term? Aryan. Integration of the first term. If you consider the first term, what is its answer? Integral of first term is derivative of denominator is in the numerator, but The derivative is within the denominator. Then what is the answer?
No.
It is? Sania, give the answer, Sania. Derivative of denominator is in the numerator, but the derivative, but the function in the denominator is within the root. So it is 2 into root of x square plus 4x plus 5, isn't it? Minus, take this as I1. So name this as equation 1. Okay. Now take the I1. Take I1 alone. So what is I1? I1 is equal to integral of root of x square plus 4x plus 5 into dx. So if you take this function x square plus 4x plus 5, coefficient of x square is already 1. So we can make it easily, isn't it? Half the coefficient of x the whole square plus 2 square minus 2 square plus 5. If you take the, yes,
I1 is equal to 1 by root, right?
yes. First one,
This I1 is equal to integral of 1 by root of x square plus 4x plus 5, right?
what is integral of 1 by root x into dx? If you integrate this, it is x raised to minus half, isn't it? So when you integrate this, x raised to minus half plus 1 by minus half plus 1 plus c, isn't it? So it is x raised to half by half. So it will be 2 root x. Is or no? Is it?
Yes.
So is your doubt clear? No, yes. Yes. Yes, Achut. Is it okay? Gauri, what is the doubt you asked?
Ma'am, I1 is equal to
So it is x plus 2 the whole square plus 1 square. So we can write this as integral of 1 by root of x plus 2 the whole square plus 1 square into dx. So it takes the form integral of root of x square plus a square. What is integral of root of x square plus a square? It is, what is integral of 1 by root of x square plus a square? It is log x plus root of x square plus a square, isn't it? Plus c. Substitute this in 1. Substituting in 1, we get I is equal to 2 into root of x square plus 4x plus 5 minus log of x plus 2 plus root of x square plus 4x plus 5 plus c. Okay. Okay, children? Hmm? Okay. Is it okay? Completed? Now write the next heading. Next type we are going to start is integration of algebraic functions using partial fractions. Integration of algebraic functions using partial fractions. Write the heading. Integration of rational algebraic functions using partial fractions. Integration of rational algebraic functions using partial fraction. Okay, here we'll be using the long division and all. Here, one thing you have to notice this is here in this method. We can use this method. Okay, suppose rational function means it takes the form like this. F of x by g of x. Earlier we did some question linear by quadratic. That one also we will get here. Okay, but some questions we will not be able to do it by using partial fraction. Some questions will not be able to do it in the previous method, that is linear by quadratic form and all. So, okay, we'll be learning all the methods, and when the question is given, some questions you can solve it by both the methods. Okay, when we discuss it, okay, we can discuss about that and all. Now, first listen. Rational means it has numerator and denominator. So here the function takes the form integral of f of x by g of x. And we can use this method only if degree of f of x is less than degree of g of x. Whenever the degree of the numerator is less than degree of the denominator, we can use the method of partial fraction. We can use the method of partial fraction. Okay, so in partial fraction, okay, we have some formulas, and not formulas, some method we will follow. For example, look at here. Okay, so what is the method we will do is, suppose we have a function like this. Okay, numerator, suppose it is a rational function with the degree of numerator is less than degree of denominator. Okay, degree of numerator is less than degree of denominator. So the given function, we make it into parts. We make it into smaller parts. That is why we call it as partial. We are making it into parts of fraction and then we integrate. For example, okay, suppose the question is of the form x minus a into x minus b. So look at the degree of the numerator. What is the degree of the numerator here? 1 means constant. So what is the degree of the numerator? 0. Look at the denominator, x minus a into x minus b. So degree is 2, isn't it? X into x means it will become x square. So degree is 2. So if it is like this, and look at the factors. Look at the factors. Each factor is a linear factor. Each factor is a linear factor. So we can split this as a by x minus a plus b by x minus b. Is it clear? We make it into 2 parts. If it is like this, okay, we split like. Suppose we have 3 factors. Suppose it is x minus a, x minus b into dx, x minus b and x minus c. Here also the condition is satisfied. Degree of the numerator is less than degree of the denominator. So we can split this as a by x minus a plus b by x minus b plus c by x minus c. We divide this into 3 parts. When you divide this also, here, look at here. Here, degree of the numerator is 0. What is the degree of the denominator? 1. Yes or no? Here also the condition is satisfied. Degree of the numerator must be less than the degree of the denominator. Okay. Suppose the function is like this. Degree integral of 1 by x minus a into x minus b the whole square. 1 by x minus a into x minus b the whole square. So here, look at this. X minus a and x minus b. X minus a is also linear factor. X minus b is a linear factor, but that factor is coming 2 times. It is having 2 times. So in that case, we split this as a by x minus a plus b by x minus b. Look at this. With this, we can't stop. C into x minus b the whole square. Okay, step by step only we can increase the powers. So here a by x minus 8 is only 1 time. But if you look at the next factor, x minus b the whole square, we get this as 2 times. Same linear factor is occurring 2 times. So how we can split this? B by x minus b plus c by x minus b the whole square. Now look at this factor. Suppose we have like this. 1 by x minus a into x minus b the whole cube. How we have to split? It is a by x minus a. It's also a linear factor. So we write this as b by x minus b plus c by x minus b the whole square plus d by x minus b the whole cube. Like this, step by step, we have to increase the powers. Is it okay? Is it okay up to those children? Okay, whenever we do the problem by partial fraction, the one thing we have to check is degree of the numerator is less than the degree of the denominator. Is the condition satisfied? That is the thing you have to check. And if it is linear factor, numerator should be degree 0, constant term. So a by x minus a plus b by x minus b plus c by x minus b the whole square plus d by x minus b the whole cube. If the same factor is repeated again and again means we increase the powers 1 by 1. Now, the next type. Look at the next one. Suppose it is like this. Integral of 1 by ax square plus bx plus c into dx. So here we have quadratic, isn't it? We have a quadratic function. So here, earlier we have discussed one method, isn't it? Earlier we have discussed one method. So, into 1 second, children, you change it as p, q and r. So in linear, you take it as x minus a. P, q, r. Px square plus qx plus c into x minus a. Suppose we have one quadratic and linear. Okay. So we have product of 2 things. Here also the condition is satisfied. Degree of the numerator is less than degree of the denominator. So in that case, what you can do, we can write this as integral of, for the linear factor, we can write this as a by x minus a. For the quadratic, listen here, quadratic is px square plus qx plus r. We will write this as bx plus c. Bx plus c by px square plus qx plus r. When we write quadratic in the denominator, numerator must be 1 less than that. So numerator is 1 less than 2 means linear. We should write a linear function in the numerator. Whenever we get linear, numerator is constant. If we get quadratic in the denominator, we will get linear in the numerator. Is it okay? Is it clear, children? Whenever we get quadratic in the denominator, how we have to factorize it? How we are splitting it? A by linear plus linear by quadratic. Whenever we split into partial fraction, the degree of the numerator must be less than the degree of denominator. That is the principle we have to follow. Okay? So once you copy this one, we can start doing the problems from this part. Okay, write the question, children. Integrate. Integrate 3x plus 2 by integrate 3x plus 2 by x minus 1 into x minus 2 into x minus 3. Integrate 3x plus 2 by x minus 1 into x minus 2 into x minus 3. So whenever you are given a problem like this, first you check what is the degree of the numerator. Degree of the numerator is 1, isn't it? And what is the degree of the denominator? 3. Okay, all of you don't. Okay, sit straight. Keep your pen down. Sit straight and listen, all of you. Okay, how we are going to solve this? It's an easy method. It's an easy method, not a tough one and all. So if whether the condition is satisfied, check it here. Whether the degree of the numerator is less than the degree of denominator. Is it satisfying? So what we can do, if it is like this, this function 3x plus 2 by x minus 1, x minus 2 into x minus 3, we can split this as a by x minus 1 plus b by x minus 2. Don't write, children, plus please listen. C by x minus 3. All the factors are linear. So 3 factors are there, 3 linear factors are there. So we write this as a by first factor, b by second factor, c by second factor, third factor. Now here you take the LCM. When you take the LCM, what you will get? X minus 1 into x minus 2 into x minus 3. With a, we will multiply x minus 2 into x minus 3. Which all the terms not there, with that we multiply. With b, we will multiply x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. So 3x plus 2 is by x minus 1 into x minus 2 into x minus 3 is like this. Up to this step, is it okay? Is it clear? Don't write, first listen. Alvin, Sania, Achyut and all, is it okay? Aditya? What we did here? We have 3 linear factors. So we write this as a by first factor plus b by second factor plus c by third factor. Then we take the common LCM, like what we do with numbers. Okay, 3 factors are there. So if you take the first one, which all the factors not there, with that you multiply. If you take the second factor, we'll multiply with the factor in the first one and the third one. And with the third part, first 2 factors we multiply. Up to this, is it okay? Now the denominator is same, so we can cancel it. So we can write this as 3x plus 2 is a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Where this a, b, c are unknowns. A, b, c are unknowns. We want to find a, b and c. How to find this? One way is by equating the coefficients. You can equate the coefficient of x. You can equate the coefficient of x square. Another method is there. What is the other method? While finding a, I want to make b and c as 0. We can substitute some values for x. We can make b and c as 0. Look at the terms b and c. Which factor is common there in b and c? Along with b and c, which factor is commonly present? b into x minus 1 into x minus 3, c into x minus 1 into x minus 2. Which factor is common there in b and c?
X minus 1.
X minus 1. So what I am going to do is, you put x is equal to 1. Why? X minus 1 I should make 0. X minus 1 should become 0, means x value is 1. So you put x is equal to 1. So when you put x is equal to 1 here, you will get 3 into 1 plus 2 is equal to a into 1 minus 2 into 1 minus 3 plus b into 1 minus 1. It will become 0 plus c into 0. So we'll get 5 is equal to a into minus 1 into minus 2. Therefore, a is 5 by 2. Is it okay? The value of a is 5 by 2. Have we got this value? In order to find a, you try to make terms with B and terms with C as 0. So to make this as 0, you look at the term which is common factor. Here in both the terms, we have x minus 1 as common. So we should make x minus 1 as 0. So that means the value of x will become 1. Is it okay? Now look at the next one. Next, we want to find B. If you want to find B, which term should be made 0? A and C should be made 0. We want to find B. So the other two terms must be made 0. Now look at these two terms. In the terms with A and the terms with C, which factor is common?
X minus 2.
X minus 2. Is it okay? Is it clear, Rijas? That is Rijas. Is it okay, Dia?
Yes, ma'am.
So if you want to find B, you look at the terms A and C. In the terms with A and the term with C, look at there which is the common factor. So in these two terms, the common factor is here with A and C. X minus 2 is common. That means what we have to substitute? We have to put x is equal to 2. So when you put x is equal to 2, it will become 3 into 2 plus 2 is equal to A into, here it is 2 minus 2, 0. A into 0 plus B into 2 minus 1 into 2 minus 3 plus C into, first one will become 2 minus 1, 1 into next is 2 minus 2, it is 0. So we will get 8 is equal to B into 1 into minus 1. So we get B is equal to minus 8. Minus B is 8, therefore B is equal to 8. Joseph, sorry, not Joseph, Emmanuel, is it clear?
Yes, ma'am.
Is it okay? Finding A and B, is it okay? Now tell
Yes.
me, how will you find C? What is the substitution you will do to find C?
Take 3 as common.
Put x is equal to 3. Okay, why we take x as 3? X minus 3 is the common factor. X minus 3 is the common factor. So you put x is equal to 3. So when you put x is equal to 3, so put x is equal to 3. So we'll get 3 into 3 plus 2 is equal to A into 3 minus 3, A will become 0. B term also will become 0 plus C into 3 minus 1 into 3 minus 2. So 3 3s are 9, 9 plus 2 is 11 is equal to C into 2 into 1. Therefore, C is equal to 11 by 2. We get C is equal to 11 by 2. C is 11 by 2. So we got the values for the unknowns. A is 5 by 2, B is minus 8, and C is 11 by 2. A is 5 by 2, B is minus 8, and C is 11 by 2. Okay, so once we find these values A, B, and C, what we can do? We substitute in the beginning. Okay, here, in the beginning, we wrote like this. Look at here. This function we are going to substitute. 3x plus 2 is equal to x minus 1 into x minus 2 into x minus 3. Now we got what is A, what is B, what is C. Substitute here. So when you substitute it here, okay, I'm substituting this here. So when you substitute it, I will become, look at your children, I is equal to, instead of writing the function 3x plus 2 by linear factors, you write the values of A, B, and C. So I is equal to integral of, what is the value of A? 5 by 2 by x minus 1 plus B. What is the value of B? Value of B is minus 8 by x minus 2 plus C. What is the value of C? 11 by 2 by x minus 3 into dx. Up to this, is it clear? Is it okay? Alvin? Sania? Yes, Alvin. Sania, is it okay?
Yes, ma'am.
Okay, so actually, if you look at the given function, it is a single function, isn't it? Now, what we did, we divided it into 3 parts. We are reducing the powers. So, we look at here. Now, we can integrate this easily. Okay, so now we can integrate this easily. So, we can write this as 5 by 2. If you take the first part, 5 by 2 is constant. 1 by x minus 1 into dx. Now you take negative x outside. So 1 by x minus 2 into dx plus 11 by 2 into integral of 1 by x minus 3 into dx. So now what is the answer? What is integral of 1 by x minus 1? Aditya?
X raised.
No. Look at there, whether the derivative of denominator is in the numerator. What is the derivative of x minus 1, Aditya?
1.
So what is the answer?
X
Yes.
minus 1 plus.
Yes, it is log of x minus 1. Minus 8 into here also. The derivative of denominator is in the numerator. So log of x minus 2 plus 11 by 2 into log of modulus of x minus 3 plus c. This is the answer. Okay. So we are given with a big expression. We simplify this, okay, using the method of partial fraction. And then we integrate. So this method is called integration of rational functions by partial fraction. And we can use this method only if the degree of the numerator is less than the degree of denominator. Is it okay? Is it okay, children? Huh? Okay, now I'll start writing. Go through it, solve it by yourself and check, is it okay? Okay, from the first part, I'll share it. So once you write this part, you tell me, okay? I'll scroll it accordingly. Srihari? Okay, once you write this part, tell me. Okay, I'll scroll it. Atul, is the method okay? Atul, Nandana?
Yes, ma'am.
Atul?
Yes, ma'am.
Emmanuel, shall we do the next one? Ready? Shall we do the next one? In the same method. Huh? Achyut? Where is Achyut? Finished writing?
Yes, ma'am.
Yes. What about the others? Aryan? Shivani? Now write the next one. Write the next one. Integral of x minus 1 by x minus 1 by x plus 1 into x minus 2 into dx. X minus 1 by x plus 1 into x minus 2 into dx. Okay, so listen, once this question is asked for the exam, the question will be like this: simply integrate. Which method you will use here? How many methods are there for solving this question? And which method you will prefer here? How many methods are there? Which are the methods you will apply here? Look at here. Gauri is present. Gauri? Gauri?
Yes, ma'am.
Ah. Yes, tell me. Atul?
Linear by quadratic.
Very good. We can go with linear by quadratic. Okay, although it is given as factor, you can expand it and we can make it as linear by quadratic. We have learned one method earlier, is or no? That way also we can do. Or now we have learned another method. What is the next method? Partial fraction. Okay. Two methods are here. Okay, if you open this, when you open the bracket, you'll get quadratic. So you can use linear by quadratic. And the second method is here by partial fraction. But the easy way, I suggest you to go with partial fraction. Okay, look at here. Okay, so look at here. So the degree of numerator is less than the denominator. So in partial fraction, how we will do this? We write this as a by first factor plus b by second factor. Next step, you take the LCM, isn't it? We cross multiply. So when you cross multiply, a into x minus 2 plus b into x plus 1 by x plus 1 into x minus 2. So denominator will get cancelled. We get x minus 1 is equal to a into x minus 2 plus b into x plus 1. So our aim is to find the unknowns a and b. So Dia, what is the substitution you will do here to find a? To find a.
X is equal to negative.
Very good. You put x is equal to -1. So when you put x is -1, -1 is equal to a into -1, -2 plus b into this one will become 0. So -2 is equal to -3a. Therefore, a is equal to 2 by 3. After finding a, to find b, what is this next substitution? You put Achyut, what is the next substitution? To find b. Put x is equal to 2. Yes. So we get 2 minus 1 is a into 0 plus b into 2 plus 1. So we get 1 is equal to 3b. Therefore, b is 1 by 3. So a is 2 by 3, b is 1 by 3. So substitute here. I is equal to integral of the value of a is 2 by 3 by x plus 1 plus 1 by 3 by x minus 2 into dx. So now we can split this into two integrals. 2 by 3 into integral of 1 by x plus 1 dx plus 1 by 3 into integral of 1 by x minus 2 into dx. So it is 2 by 3 log of x plus 1 plus 1 by 3 into log of x minus 2 plus some constants. Is it okay? Is it clear? Okay, this method we call it as integration by partial fraction. We divide it into parts. Very big expression, we make it into parts and then we integrate. Okay. Okay, children. Sania, Bunya, okay? Okay. So with this, once again.
Ma'am, can you move
Which part? This part.
left side?
Is it okay? Achyut, finished?
No, ma'am, just one.
Okay, Sar is waiting. Make it fast. Gauri, is it over?
Yes, ma'am.
Sania?
Yes, ma'am.
Okay. Okay, children. With this, we end the session now. Thank you.